Cool. Just give me a minute, guys. So how was the session so far? And how was the experience of learning DSA? It was good. What about others? I'm not seeing the active response. Aman, Abhijit, Ashish, Bhuvni, it's good and learning. Gaurav, Kalidas, Kishan, Mohan, Sai, Sangram, Swati. What about others? Please respond. See if you're not responding, how we can proceed further and how can you clarify your doubts. Okay. Guys, are you able to view the screen? Yeah, I will be sharing the link of the whiteboard so that you can access it. Cool. Are you able to view the screen? Everyone, please give the confirmation. Okay. So any idea what we're going to learn today? Anyone? Any idea? Hashing. Okay. So update was given it to you, right? Okay. So can you define what is hashing?
Can we
Can you
unmute and talk?
Yeah, you can say. Go ahead, Vishnu.
So it is difficult to store all the objects in the
Hmm.
memory.
Hmm.
So what we do is that we encrypt the object and
Hmm.
then retrieve using that hash key, whatever is stored.
Okay.
So it's an encrypted number which is stored in memory.
And if I want to just store 1, 10 and any other data and I don't want to encrypt it, can I still use hashing?
Yeah, in Java, we override hash code method.
Hmm.
So
So
we can
there
use
is no encryption over there.
a custom hashing by overriding the hash code.
Right. I got it. How we can do that in Java. But what I'm saying is, what's the use of hashing? Why we are applying hashing?
Security.
Security. Okay. How it will provide the security if I'm not doing any encryption? If I'm doing the encryption, that's a different story. But if I'm not doing any encryption, then how it will provide the security?
Uh, if anyone by chance hacks, he will be able to see and read that data.
What I'm saying, I'm not doing any encryption, but still, can I use hashing?
Yes.
Okay, cool. So let's try to discuss and let's try to understand. And guys, I need response from everyone. Cool. I think I made it clear. So if you'll respond, you will learn a very beautiful concepts. Trust me, when in an interview, you will write hash set or hash map. And if it's in good company, straightforward, he will ask you the question. Do you know how does hash map works internally or hash set works internally? So at that time, whatever you're learning today, it's very much helpful. Shall I proceed further? So we're gonna discuss about hashing. Let's say our standard phone numbers. If you talk about our standard phone numbers, how many digits it has? How many digits it has? It has 10 digits. Now on this 10 digits number, on this 10 digit numbers, you have to perform three operations. You have to perform insert X. You want to search for X and you want to delete X. That means you will insert a particular number, you can delete the particular number and you can search for the particular number. For example, if a new user has been added to the phone directory, I'll perform the insertion. If I'm searching whether that particular number is allocated to someone or not, I'll perform the search operation. And if particular mobile number is not active for a particular amount of time, I will delete it. Yes or no? It makes sense. So I need these three operations to perform. So where I should store the data? Where I can store the data? If I want to store this data, what should I use? Can I use unsorted array? See, any program which you run will be executed on the RAM. Guys, any program which you will run will be executed on the RAM. So whether it's stored in the array, whether it's stored in the queue, whether it's stored in the linked list, at the end it will get memory in the RAM. So we are not dealing with that. And the point is we are learning data successor algorithm. The algorithm part we can apply in using Java, using C++, using Python. So it has nothing to do with the DB. So if I say that I want to store the data, I want to store the data in my program. So I'm storing the data in my program. I can either use array, either I can use linked list. Am I making sense to you? Similarly, I prefer to store the data in unsorted array. If I'm storing the data in unsorted array, can you tell me if I want to insert, how much time will it take? Everyone. It will happen in big O of 1, big O of n. Okay, let's say it already have some numbers. Let's say 5, 10, 15. It has already 3 numbers. You're trying to insert the new number. What you will do? You will store the number at the end of the array. At the end. Let's say you want to store 17. Again, you will store at the end. Will you iterate or reach the end, or you have an access to the last pointer? Do you have an access to the last pointer? Yes, no. We have an access to the last pointer. I can maintain it. I can maintain it. For example, as of now, it contains 5 numbers. As of now, it contains 5 number. Can I say that 0, 1, 2, 3, 4, fifth index is empty? As soon as I've inserted the element over here, let's say 1, I'll increase the count to 6. As soon as I've inserted the element over here, let's take 44, I'll again increment the count. So don't you think that insertion is happening in big O of 1? Everyone, are you agreeing with me that insertion is happening in big O of 1? Yes, no? Am I going too fast? Am I going too fast? No, right? No? Cool. What about the search? If I want to search in the unsorted array, how much time will it take? If I want to search, how much time will it take? Be reasonable. It will take big O of n time, because you have to search on the entire array. When you will search on the entire array, then only you can say whether that particular element is exist or not, right? And what about deletion? How much time does deletion will take? Deletion will take big O of 1, big O of n, big O of 1, big O of n, big O of n, right? In the worst case, I'll remove the first element. I found 5, I remove 5, but I will shift remaining n minus 1 elements towards the left. So if I'm shifting n minus 1 elements towards the left, can I say that it will take big O of n time? Yes. Till now, is it clear? Pakka. Shall we move forward? Okay. 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 Let's move forward. Let's say I prefer to store the data in the form of sorted array. No, see, when you're talking about the big O, you will say big O of n, and it's not big O of 2n. Why so? Let's say you want to delete 11. Let's say you want to delete 11. Guys, try to understand. If you want to delete 11, if you want to delete 11, how many iterations would be required to find 11? Exact value, 4 iterations. 4 iterations are required to find 11. Then you will do 3 shifts. 4 plus 3, 7, which is nothing but number of elements present. So if you talk about the exact number of steps, it's still n, not 2n. Some people got confused that I'm removing from the first, so n to search and n to shift. Do you got it? That it's exact number of steps is n, not 2n. Cool. Guys, I'm still saying that some of you are responding so good, some of you are not at all responding. So cool, let's move forward. If I'm storing the data in the sorted array, can you tell me how much time will it require to insert the data? And are you able to understand the handwriting? Any issues with it? No? Cool. So if I'm storing the data in the sorted array, what should I do? What should I do if I want to store the data in the sorted array? Insertion, how much time will it take? Insertion will happen in big O of 1. Think logically. 5, 10, 11, 15, 17. Let's take that. I want to insert 1. If I want to insert 1, it will be inserted in the 0th index. If 1 has been stored in the 0th index, you will shift all the elements towards the right. Yes or no? So shifting will happen. If shifting is happening, so it's big O of n. You're shifting an elements, right? What about search? What about search? I want to perform searching. How much time will it take? Guys, it's log n because you will do binary search. It's sorted, right? I should use some advantage. Data is sorted. We will use binary search. What about deletion? What about deletion? Deletion log n. Let's say I want to delete 5. So first of all, I have to find 5. I can find 5 using binary search. So it will take log n. But once I find 5, I will remove it. If I'm removing it, I'm shifting the data towards the left. Shifting will take again n time. So it's overall big O of n. Am I clear to all? That's in sorted array will take this time and unsorted will take this time. Can you tell me any other data structure where you want to store the data? I'll take the data structure of your choice. Whatever you have studied so far, you can let me know. Had you studied linked list? Yes, no? No. Okay, if linked list is not studied, you would have probably won't study trees as well, right? So you will understand the complexity of insert, search, and delete when you will learn linked list, cool, and when you will learn trees. So in your notes, just keep the space for it. Once you learn linked list and trees, you can fill it up. Am I clear? Am I clear to all? Right. Let's move forward. Let's move forward. See, I don't want to perform the operation in big O and it's taking too much time. What's the best case scenario of insert, search, and delete? What's the best case scenario? Everything is happening in big O. Am I correct or not? Insert, search, and delete. If everything is happening in big O, it would be something like getting the lottery. Am I correct? So what I'm proposing the system. If you want to store 10, what you can do, go to the 10th index of your Boolean array and make it true. If you want to delete 10, what should you do? You should go to the 10th index of an array and make it false. This was for insert, this was for delete. And if you want to search, you can simply check what array of 10 is storing. If it's storing true, that means element is present. If it is storing false, that means element is not present. Yes or no? Guys, do you get this or not? Please repeat. Okay. Leave the 10-digit mobile number. Let's say you want to insert the data from 1 to 100. Okay. 1 to 100. Clear? 1 to 100. Now, if you want to store the data from 1 to 100, I ask you to store 50. So you have an Boolean array which can store, which is having the size 101. Why 101? Because the last index which I want is 100. If last index is 100, index plus 1 is the size. Do you get it? Now what I'm saying is, if you want to store 50, you should go to array of 50, and by default it will be storing false. By default it will be storing false. So array of 50, make it true. So can I say that 50 index has been occupied? So can I say that this is an insert operation? Now let's say if you want to delete 50. If you want to delete 50, you can go to the 50th index and make it false. Can I say that deletion is being done? Yes, no. And if I want to search, I can see what's the value stored in array 50. Guys, what I'm saying is, if value is between 1 to 100, why someone will give 101? Let's say you are having a locus. With respect to the each locker, there is a key. So when customer is giving you the key, you are giving the key to the customer, you will mark it as an occupied. Yes or no? In your diary or in your notes, you will say, okay, this particular counter has been occupied. Occupied means it's true. If it's empty, what you will do? If someone is returning the key, what you will do? You will mark that particular locker as unoccupied. If you want to mark that particular locker as unoccupied, you will make it false. And you want to check. Let's say you are in the hotel. You want to check whether particular room is allocated or not. You can simply check with respect to that particular number, what is the entry? Is it true or is it false? Make sense? Understood? Acha. Now if I'm storing 10 digits mobile number, if I'm storing 10 digits mobile number, 10 digits mobile number, what would be the size of an array? And what's the largest 10 digit number? Can anyone tell me largest 10 digit number? All 9? Am I correct? All 9? So 9 has been repeated 10 times. So if in 91, if in 99, if I will add 1, it will become 100. 1 followed by 2 zeros. If in 9, if I will add 1, it will become 10. 1 followed by 1 0. So in 9999 till 9, if I will add 1, it will become 1 followed by 10 zeros. So can I say that 10 the power 10? Logically, it makes sense. This is what we did. If I need an index 100, size was 100 plus 1. If I need the last index to be this index plus 1 would be the size of an array. Can you tell me how big this value is? 10 the power 10. Assuming that this is in Boolean array, how much memory is this? Take your time, do the analysis. I'll give you 2 minutes. It's more than enough, I guess. Please make the analysis and let me know. Because if I'll say 10 the power 10, you're not getting any vibes how big it is. Acha. Can I say that? Can I say that in this array I can store 10 the power 10 Boolean values? Each Boolean will occupy 1 byte. So all it is 10 the power 10 byte. Yes. Now I'm doing some approximation. So we should be very, very attentive. In 1 kilobyte, how many bytes are there? In 1 kilobyte, how many bytes are there? 1024 bytes. Am I correct? Can I approximately say that 1000 bytes? I'm just removing this 24. Approximately 10 to the power 3. If in 1 KB there are 10 to the power 3 bytes. Now what you're doing? In 1 MB, how many kilobytes are there? Kilobytes. In 1 MB, how many kilobytes are there? 1024 kilobytes. Approximately 10 to the power 3 kilobytes. Yes. In 1 kilobyte, there are 10 to the power 3 bytes. So can I say that in 10 to the power 3 kilobytes, there would be 10 to the power 3 into 10 to the power 3, which is nothing but 10 to the power 6 kilobytes. Sorry, 10 to the power 6 byte. In 1 MB, there are 10 to the power 6 bytes. Till now, is it clear? It's clear to Kishan. What about others? Please respond if it's clear. It's clear to Vishnu. Bhuvnesh, 3. Others, are you there? Clear to Gaurav? Shall I move forward? Right. Similarly, in 1 gigabytes, how many MBs are there? 1024. Approximately 1000 MB. 1000 MB is nothing but 10 to the power 3. In 1 MB, there are 10 to the power 6 byte. So in 10 to the power 3, it would be 10 to the power 3 into 10 to the power 6 byte, which is nothing but 10 to the power 9 bytes, right? Now, 1000 is 10 to the power 3. Can I write it as 10 into 10 to the power 2? 10 to the power 2 is nothing but 100. Can I write it in this manner? Similarly, here we have 10 to the power 10 bytes. Can I write it as 10 into 10 to the power 9 bytes? And 10 to the power 9 bytes is equal to what? 1 GB. So you're using 10 gigabytes of memory in order to achieve it. Everything looks good, awesome, but 10 gigabytes of memory. It's huge. Imagine running a single program which will consume 10 gigabytes of memory, RAM. And you know, RAM is costly, right? Now, this is a very short explanation of hashing. We perform hashing. We perform hashing to get an advantage of direct access table, but use a feasible amount of space. See, where you were going to that particular index, making the things true, false, and searching for it. This concept is called as DAT. DAT is nothing but direct access table. So you want the advantage of direct access table, but as well as you want to provide a feasible amount of memory. Are you getting the point? That's why we use hashing. How it will be done? It's a different question. But you understand why we are performing hashing? What was the root cause that we have looked towards the solution as hashing? Guys, yes, no. I want an advantage. DAT is nothing but direct access table. You mapped a particular number with the particular index of an array. So you're directly mapping the number with the index, right? Number was directly mapped with the index, right? So this was called direct access table, DAT. Cool. Shall we move forward? Shall we move forward? We are done with the DAT. See, of course, we would have been explored graph. Sorry, we would have explored. Yes, Vishnu, go ahead. What's your doubt? Could you just raise hand? Vishnu, can you please raise hand? Yeah, go ahead, Vishnu.
So actually my doubt is like,
Hmm.
this 10 GB is data is used when all combinations of 9 digits are used. So
No.
starting from all zeros to all nines.
Okay.
But if it is a single 10 character,
Hmm.
then it will be less.
The point is, before even performing your insertion and delete, you're creating an array of size 10 to the power 10.
Yes.
Yes. So as soon as you will create this, by default it will store false.
Yes.
So it will occupy the memory,
Yes.
which is nothing but 10 gigabytes.
Yes. So any mobile company can afford to have 10 GB. I'm just trying to think it like in a different way.
Mhm.
So then a database with 10 GB data is not that big.
In terms of database, it's not big. What I'm trying to say that you have declared the memory of 10 gigabytes. But let's say I want to store only 10 to the power 6 numbers,
Yeah.
which is nothing but approximately it should consume 1 megabytes.
Yeah.
But I want to store 1 megabytes of data. For that, I am declaring a space of 10 gigabytes. Does it have any connection?
I didn't get that. Why declaration will
See, the point is you declared it.
okay.
As soon
Oh,
as you will declare an array, it will occupy some space.
yeah.
So the space which will occupy is 10 gigabytes.
Yes. Yes.
Now I want to insert 10 to the power 6 number,
Okay.
10 to the power 6 unique number. If I'm doing that, that means these many data is being stored. So if you'll try to convert 10 to the power 6 byte, it's nothing but 1 MB. You've seen our conversion.
Yeah. Yeah. Yeah.
So I
So
want to store a very small amount of data. For that, using 10 gigabytes and blocking that space, it's waste, right?
yeah, I get that point that, just to allocate that much space,
Hmm.
we will require 10 GB of RAM, which is like none of them
Waste.
our machine has. Yeah, but I think it comes back to just we are storing like 10 phone numbers. For 10 phone numbers, we just need 10 into 10 characters space, which is like you.
That's what I'm saying. That's what I'm saying. We can do that. But the logic which we are using, first of all, you're creating an array.
Okay.
You haven't stored anything into an array, but by default, it will be storing false.
Okay.
So this will also occupy some memory,
So I get that initialization will take the
right?
that much space. Okay, got it. Okay, I'm cool.
Okay. Thanks, Vishnu. Cool, guys. Let's move towards the hashing. Let's move towards the hashing. Now, what does hashing say is that we were earlier treating the phone number as the index of the count array, right? We were treating the phone number directly with the index. Yes or no? We did that. I don't want to do that. I don't want to do that. Instead of that, we will somehow apply a function to this phone number and reduce it to the smaller value. Then I will store, right? How? Let's see that. There is a function called hash. Hash of x equal to x mod s. What is s? S is nothing but size of your hash table. That means the array where you're gonna store this value has the size s. Okay. Wherever you wanna store the value, it has the size s. Is it clear? What is x? X is the value which you want to store. X is the value which you want to store. And where you will store that value, you will store the value, whatever the result is given by x mod s. This will give you index. Let's try to take the example and understand that. Okay, can you tell me? You will say, sir, how it's possible? How it's possible? Let's see. For example, I'm taking the number 100. I think it's too much zoom out. Let me zoom in and change the color to, yeah. Are you able to view the color or is it too light? Guys, visible? It's okay, it's fine. Let's take 11 little light, right? Okay, let me change it to some dark color, I guess. Okay, the point is we have done so much of zoom out, that's why it's giving an issue. Okay, is it visible now? 100. Okay, let's take that. I did 100 mod 10. Can you tell me the result? 0, because mod will give you the reminder. If I did 98 mod 10, what you will get? Right now, if I did 99 mod 10, what you will get? 9. If you did 45 mod 10, what you will get? 5. Can I say that every time you're getting the value between 0 to s minus 1? And these many indexes we have? Logically think that these many indexes we have? Yes. So can I say that I've solved the problem? Even the number is too big. Even the number is too big. It is paired with the index which is in this range 0 to s minus 1, and I'll declare an array of reasonable size. I'll not declare an array of size 10 to the power 10. I will declare an array of reasonable size. Can I say that I have solved the problem? Kishan is agreeing with me. What about others? Do you agree with me or not? Gaurav, yes. 2. Vishnu, no. Cool. 3. Okay, I got 3 positive response. Let's move forward. And here you will get it. Here you will get it. Of course, you will run into the new problems. That's a different thing. Let's say that S is 10, size is 10. Okay. Now I want you to answer the following questions. 3, 4, 5, 6, 7, 8, 9. Fine. You know, I haven't counted while putting this partition that how many I'm about to pick. Luckily, it was 9. That's why I was counting it. Cool. Let's say I want to insert 3. Where 3 will go? If I want to store 3, at which index 3 will go? 3 mod 10 will give you what? 3. It will go in the third index. What about 17? Where 17 will go? 17, 17, 7. What about 48? 48 will go at the 8th index. Correct. What about 6? Okay, 6. Now, see, if you take any very big number, doesn't matter. If you're doing mod with a particular value, you will always get the result between 0 to 9. If it's mod with 10. Okay, right. Now let's say I want to store 97. Where 97 should go? Ideally, it should go to the 7th index. But 7th index is already filled. So we solve the problem of the space, but we run into the new problem. What's the new problem? The new problem is nothing but collision. Collision, right? Two hash keys are fighting for the same index. You've seen that in the real life. Two people are fighting for the same thing. Yes, no, always. Are you able to relate? Suppose you went to the shop, there is only one item available. Okay, okay. So yeah, it happens lots of time. Now, same seat in the train, but that's not practically possible. Same seat in the train. In the metro, you can fight. One space left, two people are about to seat. Yes. And in Hindi, there isn't one idiom for it. Ek anar, 100 bimar. Heard about it? Yes, good, good, good. Right. Okay, let's move forward. So the point is we run into the new problem, which is nothing but collision. So what do you mean by collision? Can I define two different? Guys, I used to write less. I used to speak more. So you have to focus. Two different hash keys giving the same hash value. Hash value is nothing but the index where you're about to store the object or your value. Am I clear so far? Now, whenever there is a problem, there should be a solution. Wherever there is a problem, there should be a solution. So there are two solutions for this. One is open addressing. One is open addressing. And second one is separate chaining. Now I'll say that if you want, I can also teach you open addressing. I can teach you open addressing if you're interested. As of now, let's keep it aside. Why so? Because your Java prefers separate chaining. And I think everyone is here from the Java background or any other programming language. Please let me know if you use any other programming language apart from Java. Java? Yes? No one? All Java? Good. So Java prefers separate chaining. So in interview, if he's asking me about the internal of hash set and hash map, I should give him answer with respect to the Java, right? I should not tell him about any other language how it works. It makes sense. So if for your knowledge, I'll teach you later if you want, if you're interested to know. But as of now, let's focus on separate chaining. What does separate chaining says that? What does separate chaining is that? Guys, are you ever declared array list of integer? Had you ever declared this array list of integer? So what used to happen? What used to happen? There is an array list. There is an array list. What I'll do? Let's say that the size of this array list is 10. The size of this array list is 10. 0, 1, 2, 3, 4, 5, 6, 7. I need 3 more blocks. And guys, whenever you have doubts, you can raise hand. You can let me know so that I will allow you to unmute and you can clarify your queries. 8 and 9. So guys, as soon as I've created an array list of size 10, what I did, by default, it will be storing null. Yes or no? Guys, yes, no. If I will create an array list of size 10, by default, it will be storing null at all the 10 indexes. So what I did, I iterated over this array list and replaced this null with an address of new array list. An address of new array list. Is it clear, everyone? Yes. So the point is or array list stored over here or the reference of the array list is being stored? Guys, think logically. Array list is being stored or the reference of array list is being stored? Reference. Everyone agreed with me? Reference is being stored. Now let's try to do the trace again. I want to again store 3. Where 3 will go? Where 3 should go? On the third index. So what I will do, I'll store 3 not at the third index, but I will store 3 in the array list which is present in the third index. In the diagram, I'm representing it in this manner. Now, what I want to store? I want to store 17. If I want to store 17, where it will go? At the 7th index. That means array list which is present in the 7th index. Now I want to store 48. 48. It will go to the 8th index and it will store. Am I correct? What about 6? It will go to the 6th index and it will store it. Now 97 comes up. Where 97 should go? To the array list which is present in the 7th index. Are you allowed to store multiple values in the array list? Problem solved? Yes, no. Problem solved? Cool. Good, Vishnu. What's your, okay? I think it's clarified now. Or you still have doubts, Vishnu? Doubts? Just raise hand. Yeah, go ahead, Vishnu.
Actually, my question is that so we have we are talking about this separate chaining
Right.
in this context. So every number,
Hmm.
I mean, I couldn't correlate like how this chain and array list are correlated because the collision is still there.
Collision is still there. Okay. Let's say you got 17. For 17, what you did? You first calculated the hash value. How you calculated the hash value? You did 17 mod 10. You got
Not
7.
yes.
Okay. Then what you did? You called al dot get of 7. You got the array list which is present over here.
Yeah.
And can I call list dot add 17? Can I call?
Yeah.
So can I say that in this list, in the list which is present in the 7th index, 17 is being added?
So once again, it will do the same thing, meaning it will go to the 10th, I mean, it will go within this at the 7th position and then put,
The
means,
point is here
yeah,
array list is stored or 17 is being stored?
uh, yeah. How will 17 be stored? Will it be,
17 is not stored. It is stored in the array list which is present in the 7th index.
okay.
In
Okay,
this
I
index,
think,
an array list is there.
yeah,
I am retrieving that array list by calling al.get of 7.
right.
As it is an array list, can I store multiple values?
Yes,
So list.add 17 is being added as of now in this array list.
yes,
Again, you got, let's say, 97. You calculated the hash value, which is nothing but 7,
yes,
right? You'll again call al.get of 7.
yes,
So it will give you an array list which is present in the 7th index.
yes.
Can I call list.add 97 into that array list? Will that array list will be able to store 97?
Um, so
That's,
it will create a new object and then add that to avoid collision.
see, no, why? Let's the game object will be there. Can I call? See, just assume that there is an array list.
So once again, 17 will be replaced by 97. Is that what
Why?
you mean?
Why? Okay, let's say there is an array list.
Yeah.
Name x. Can I call x dot add of 1? Can I call x dot add of 10? Will 1 will be replaced? Or this array list will store 1 and 10 both?
Yeah.
It will store both.
Both. Yes.
Same thing. I'm retrieving the array list which is stored in the 7th index.
Okay.
And in that list, I'm updating it.
Yeah. See, from
Vishnu.
this angle, I am clear.
Hmm.
But once I was thinking in your, like in the old way, where we are storing at the old place,
The point
then,
is in the old way, it was having the values, not the reference. So if
okay.
it's an integer value, you can store only single value over there, right? So it will do the replacing. That was the problem which is solved by an array list.
Okay.
Do you
Yeah.
are
So,
you able to read it
yeah.
now?
Yeah. So now I'm clear that we are storing just the reference or the memory location, not the data.
Exactly, not the exact value.
Okay. Got it.
Cool. Thanks, Vishnu. Everyone clear with this? Sure. Shall I move forward? Now, So tell me, if I'm distributing them in the different indexes, if I'm distributing them in the different indexes, let's say I want to search for 97. Will you search in the all the array list which is present in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or you will go to the particular array list and search? You will go to the array list which is present in the 7th index, then you will search. So instead of searching in the entire area, you're searching at the particular list, right? You're searching in the particular list. Can I say that searching will take big O of L time? L is nothing but length of this list. Can I say that? Length of the list. Can I say that? And what about the insertion? How much time will it take you to insert the value in the array list? Guys, how much time is it required to insert the value in the array list? Array list is nothing but internally an array, and you're storing the value at the end of an array, which can be done in big O fun. Yes. And if you want to delete, how much time will it take? If you want to delete, how much time will it take? Guys, if you want to delete, what you will do? Let's say you want to delete 97. First of all, you won't go to the remaining blocks. You will go to that particular block. And in that particular block, you will search and delete. So can I say that it's again equal to big O of L? Remember, we have seen the complexity for the unsorted array. So your array list is nothing but inside an array. Internally, it's an array, right? And we are storing the data not in the sorted format. So it's an unsorted array. Am I making sense to you, guys? So do you think that it's a better solution? It's a better solution. Yes, no, it's a better approach. But again, there is a problem with it. What's the problem with it? What's the problem with it? I want you to understand two things. Again, let's say if 17 comes, will you directly store 17? Again, 17 comes up, you will directly store 17. Again, 17 comes up, you will directly store 17. Don't you think that unnecessarily length of the list has been increased? Just to perform insert in big of one, I'm increasing the length of the chain. If I'm increasing the length of the chain, my search and delete are being affected. The performance of search and delete are getting poorer and poorer as soon as the duplicate values are being stored and stored. Am I correct with this point? Everyone, am I correct with this point? So what's the best way? Do not directly insert. First search, then insert. So searching will take big O of L time, which is okay because already my search and delete was happening in big O of L. If my insert will also happen in big O of L, it's good. But if unnecessarily my chain length has been increased, that's a problem for me. Are you getting this point? So Kishan agrees with me. What about others? Do you agree? Vishnu, 2. Guys, Bhuvnesh, 3. Sai, 4. Others. Babre, 4 people are listening to the class. What about others? Okay, let's move forward. Let's move forward. So you understand that your insert, search, and delete should happen in big O of L. Insert, search, and delete should happen in big O of L. What's big O of L? We will understand later. But do you get it? It's big O of L, and L is nothing but length of the chain. Let's move forward. So I think I answered one of the question. Do you get it why hash map and hash set do not allow duplicates? You know that hash map and hash set do not allow duplicates. You know or you do not know it? You know it, right? And do you get the reason why hash map and hash set do not allow duplicates? If they will allow the duplicates unnecessarily, their search and the delete complexity will increase. It will take more time for them to search and delete. That's why they do not allow duplicates. If you want to store the duplicates, you can use the key value, you can store the key, and you can store their frequency, right? This is the solution proposed by HashMap. Am I correct? So for everything which is happening, there is a reason. There is always a why. If you know that why, things are sorted. Am I correct? So now, see, in HashMap, there are two things, right? Key and value. So your key will be 17, and number of times key has been repeated. You can call it your value as frequency. Yes, got it. Why key value pair is given. Okay, so you can use them it in this manner. Now, can you tell me can you see any other problem in this approach? Any other problem in this approach? Yeah, when it debug does not show frequency, okay, I got the point. What I'm saying is, you can, if you want to know how many times 17 I try to insert, you can store it in the key value format. Right. Now, are you facing any other issues with this approach? Something is still wrong. What's that? Let's try to understand. Okay. Let's say that I want to store 87. Where I should store 87? At the 7th index. Array list is present in the 7th index. 97, 107, 227. Now, if you want to search anything, is it big O of L or is it big O of N? If you want to search for 227, is it big O of L or is it big O of N? It's big O of N. Every value went to the same array list, but ideally it should be uniformly distributed among all the indexes which I have given it, right? It should be uniformly distributed among 0 to 9. Yes or no? So can I say that if you're creating a good hash function, if you're creating the good hash function, it should uniformly distribute the key. Correct. It should uniformly distribute the key, and it should hold one more property. See, even if you're performing insert, search, and delete, the first thing what you're doing is you're computing the hash value. You're applying hashing, you're computing the hash value. So the time taken to compute that value should be less or should be more? Should be less. So can I say that? Can I say that? Easy to compute? Yes, easy to compute. Now, what I will do, I'll perform, there is a concept called double hashing. What is double hashing? Double hashing says that to the key, do not apply one hash function, apply two hash functions to it. What? Let's say that I'll define. I will define. H1 says that. H1 says that. Give me sum of digits. And H2 says that. Tell me last digit. Okay. What does H1 says that? I'll do sum of digit mod 10. It will say that I'll find the last digit. Okay. So if you'll perform sum of digit, I'm just giving an example so that you're able to understand things in the better manner. Okay. I'm not saying exactly this will happen, but if I'm making you understand, you can make interviewer to understand. ठीक है, matter done. I know the internals. Okay. Let's say I want to store 87. What does H1 will give? 8 plus 7, 15. 15 mod 10 will give you what? Guys, 8 plus 7 mod 10. It will give you what? 5. What does H2 will give you? What's the last digit? What's the last digit? Last digit is 7. So what you're doing? H1 plus H2. That means you're doing 5 plus 7 mod 10. What you will get? 2. That means 87 will stored in the second index. The array which is present in the second index. Yes. What about 97? If you'll perform H1, what you will get? What's the sum of digit? For 97, sum of digit, you're performing H1. Sum of digit, 9 plus 7 is 16. 16 mod 10 will give you what? 6. What does H2 will give you? The last digit is 7. 7 plus 6, 13. 13 mod 10, 3. So 97 will go to the third index. Similarly, 107 will go to the different index. 227 will go to the different. I'm not saying that there won't be a collision. I'm saying that yes, of course there will be the collision because indexes are 10. And if I want to store 50 values, there would be collision. Am I correct? There are 10 index and their values are 50. So there will be a collision. But the point is values are distributed evenly now. Uniformly it's been distributed. I'm not saying exactly they will have the 555, but some will have 5, some will have 3, some will have 7. But it won't happen that one of the indexes is having 25 values and remaining are distributed. It won't happen. Am I correct? Guys, are you agreeing with me? It's not easy. And see, 1 in a million case, 1 in a million or 1 in a billion case, you will get the values which will give the same hash value. It can happen. It can happen, but 1 in a million case, right? Okay. So let's say that ideally, if I want to store 50 values, and it is distributed among 10 indexes, can I say that each will get 5? Each will get 5. If I want to perform the search, approximately it will get 5. 10 boxes, 50 candies, each will get 5 approximately. Now if you want to search for a particular value, we'll search in the entire area or you will search on that particular bucket? We'll search on particular index, a specific bucket. So can I say that it's approximately 5 comparisons? If I will double the size, size is 20. And if I want to store 50 values, how many comparisons are there? How many comparisons are there? Sorry, how many values will be there in each bucket? There are 20 buckets and 50 values. Each bucket will have approximately 3 values. Bucket is nothing but your index, approximately 2 to 3. So can I say that? Can I say that even if I have, even if I have size which is half the number of values, half the number of values, I can solve it using 2 to 3 iteration, or I can find it using 2 to 3 iterations. Can I say that 2 to 3 iterations are approximately equal to big O of 1? Approximately, not exactly. Yes, no, yes. Acha. There is one more concept. Let's say that, let's say that, what does Java used to do? Instead of array list, it used to store in the form of linked list. Instead of array list, it uses linked list. And linked list has the same complexity as an array list. So not to worry. One thing is clear. One thing is clear. It has the same complexity. Yes. Second thing, as soon as chain length becomes equal to 8 or greater than 8, your chain length becomes greater than equal to 8. What it used to do, it used to convert this chain into a tree. So you don't know the tree data success as of now, but it converted into BBST. So what is this? I can explain you if you're ready to come on tomorrow's session. I can explain you what is this BBST, and I'll make you implement your own hash map or hash set, whichever you prefer. Can we have the deal? If I will give you the break of Saturday, Sunday, you might forget what we have studied today. But once we have the implementation, everything would be new in the memory. Like it will get permanent, right? Because once you see the code, you will write some comments. Because as of now, everything is mathematical. Are you agreeing that you will come on the tomorrow session? Because I'm also running jam packed. Will come. Cool. Anyone has any doubts, you can ask. 8 p.m. same time. Sure. And if I'm not able to find the time on Saturday, I'll postpone it on Sunday. But for sure, on whether it's on the Saturday or Sunday, I'll finish it off. Cool. And if time permits, I'll explain you open addressing. This is also left. If you're eager to learn, I can explain you. Cool, guys. Do you have any doubts? Question on BBST? Right now, I cannot answer. So when I will discuss that, I can answer it. Apart from that, and was I teaching so fast? What was the pace? Nice. Enjoyed it? Cool. Okay, cool, guys. I won't waste much of your time. Thanks for today's session. Thank you. Thank you, everyone. Yeah. Yeah, same link. You can join on the same link. Of whiteboard. Okay, cool. Mm, earlier they used to give the feature. I think they have removed it or what? Not sure. Yes, good night, guys. I'm just trying to check. Yeah, yeah, I got it. Guys, just I'm sharing the link. If you want, you can use it. It's there in the Zoom chat. Yeah, I got it. Cool. Copied the link. Shall I end the meeting now? Just click over the link. It will open the web page. Yeah, I'll put it on the Telegram. I'll ask the admins to put on the Telegram. Cool. Thank you, class.